Kinematics by Katie Yutt and Liat Eben. One-dimensional motion. So basically displacement is distance with a direction because it's a vector quantity. So displacement is just d. It's just distance. Velocity is displacement over time, d over t. It's also a vector quantity, so it also has direction. Acceleration is the rate of change of velocity, so velocity over time. Two-dimensional motion is basically just motion in two directions, as the name suggests. So basically, the horizontal components and the vertical components will always be split up. Can y'all shut up? Thanks. Will always be split apart because the horizontal does not affect vertical and vice versa. Horizontal, vertical is vertical. That's good to know. Gravity is negative 9.8 meters per second squared. So basically in this video, Liat is throwing the basketball, which demonstrates two-dimensional motion because the ball goes horizontally a certain displacement, and it also goes vertically a certain displacement. At the top, it will have no vertical velocity, but it will have horizontal velocity, and throughout the whole entire thing, there's always the acceleration of gravity, and yeah. Okay, if we were going to split up horizontal and vertical components, we could use the equation d equals d initial plus v initial time plus 1/2 at squared, which basically is just the essential equation for displacement, and that is irrelevant because there is no horizontal acceleration, and this is just reduced to displacement equals initial displacement plus velocity times time, and that would just give you how far horizontally it goes in the time it takes for the ball to make it back to the ground. So basically this video shows that when I'm up on the bridge and I throw one ball horizontally, so one is going straight down and one is being thrown further and then coming straight down. This just verifies what I said earlier in that the vertical and horizontal components do not affect each other because they both hit the ground at the exact same time. It's because the acceleration of gravity is the same on both, regardless of the horizontal velocity I gave one ball, so they hit the ground at the same time, and that's how we can split them apart because we know that they don't affect each other. Gravity is an essential force because it's applicable in all one- and two-dimensional circumstances. And basically, its value is just negative 9.8 meters per second squared. The negative just implies that it's going down, so depending on how you approach a problem, it could also be positive, and it's always present, and it's just the downward acceleration that's acting on every object basically.
Okay, so now we're going to talk about momentum. Momentum is the product of the mass and velocity of an object. For example, say we had a truck with a large mass and a large velocity. It would have a larger momentum because it takes a larger and prolonged force to get the truck up to this speed. Okay, so say we had a smaller truck, a lighter one, that was moving at a slower velocity, then it would have a decrease in momentum, a less momentum. And like velocity, linear momentum is also a vector quantity, which means it possesses a direction and a magnitude as well. And its equation is P equals mass times velocity. So there are two parts of momentum, collisions and impulse. Here we're going to be talking about collisions. And there are two types of collisions. There's elastic and there is inelastic. Elastic means that the when the objects do collide, kinetic energy is conserved. And usually this leads to the two objects separating most of the time. But inelastic is when kinetic energy is not conserved, and majority of the time the objects will stick together. Okay, so you just saw an example of a collision. Specifically, what you just saw was an elastic situation, or an elastic collision. Impulse is the change in momentum. The equation for impulse is I equals F times the change in time, and F is your force. Energy is an object's ability to do work. There are three types of energy: potential, kinetic, and mechanical. Kinetic energy represents an object in motion. The formula for kinetic energy is 1/2 mv squared. Potential energy is energy stored and held in readiness due to its potential to do work. For an example, a roller coaster at the top of a hill. The potential energy is found using mass, gravity, and height, and the equation is P E equals mgh, mass, gravity, height. This video is an example of the forces of energy, potential and kinetic. When Liat holds the ball at the top, it has potential to do work, and when she drops it, that potential energy is converted into kinetic. The law of conservation of energy states that the total energy of an isolated system cannot change. It is said to be conserved over time, and you know the common saying, energy can neither be created nor destroyed, applies to this law as well. For instance, if you have chemical energy, it can be converted into kinetic energy. This is represented in the explosion of a stick of dynamite. That's supposed to be dynamite. Okay, that's really bad. Sorry. When a specific force causes an object to move a certain distance, work is done. The formula for work is W equals force times distance. Work is also the change in energy.
Okay, go.
Okay, you just saw an example of work being done. Leah applied a force to the chair and walked with it a certain distance.